that, let's talk about this whole idea of digital transformation. What is it? Well, for organizations, there is no standard definition of digital transformation. What they want to do is move from what they're doing today in whatever industry they're in and change how they do business. That might mean more competitive, offering new products and services, moving into new markets, lowering costs, whatever the case may be. And they choose to use technology to get there. But digital transformation is not one thing. It's normally made up of a group of actions, what are called digital innovations. Think moving cloud, implementing SD-WAN, advanced analytics, IoT, whatever the case may be. And these things all build on top of each other. And the end result is digital transformation. Now, in theory, one thing builds on top of each other, complements the thing that came before it, and sets the groundwork for the thing that's coming. But unfortunately, that's not always the case. Because all too frequently, all too frequently, there's a missing element in these individual digital innovations. And unfortunately, that missing element is all too often security. Security has not been part of the planning process. It's not part of the implementation process. And it's only after the fact, quite often, that they realize, hey, we've made a mistake. And it's not just making an operational mistake. It's a mistake that can lead to a data breach. And that's what I want to focus on, because we think about these things and you read the press, everything in the world is moving. In this case, it's moving to cloud. It will be the savior of all of our current problems. And it could be, but only if you do it correctly. So here's where the history lesson comes into play. Now, I want to take you back, probably a bit further than I'm even comfortable with, but back to the mid-90s. Yes, I was working in the networking industry at that time. I was about 12 years old. And this really was the golden age of networking, because this was where all the innovation was taking place. And we went from computer networking schemes to IP was coming in, Ethernet, everything was working out nicely. And eventually, we arrived at a standard network architecture, what's shown on the slide here, and this idea that my branch offices, and again, at this time, connecting up branch offices, if you were working remotely in whatever organization you were working in, there wasn't a guarantee that that remote office had access to the same applications as the people did that worked in headquarters. So as we brought these things together, this architecture became kind of the running standard. The idea that I used a service or a technology, in this case MPLS, multi-protocol label switching, which I didn't have to buy products to do this. I bought it as a service from my local service provider. They managed it. I just paid a price, and life was simple. And the whole objective for those users on some number of devices on the left-hand side wanted to get to the applications on the right-hand side. Now, those applications, remember, this is a hierarchical, top-down environment. Those applications were at the top of the pyramid. And it was the users who needed access to them. And if there was difficulty, the applications didn't change, the users had to change. How you hooked up a branch office had to change. So this was pretty good. This went along fairly well. And another piece of history, probably the more shocking one, that at about this time, the internet became a thing. And believe it or not, organizations actually debated whether they should allow employees to have internet access at work. The internet was in its early days. For a lot of people, it was just a static billboard somewhere out there. But when organizations did decide that, yeah, this internet thing is not bad, the way they accessed it was what they knew at the top of the pyramid from the data center. All my traffic was coming back to those applications anyway. So if somebody wanted to go to a search engine at that time, Ask Jeeves, for example, well, all we had to do was trombone them or turn them right back around, and send them out to the internet. All was good. But as in cases like this, it changes. The organization struggles because what happens is more and more traffic is being generated. The company continues in the public cloud, and I don't care which one you're using or talking about. It's the same phenomenon. There's also this idea of a SaaS application, getting rid of certain applications you're maintaining yourself and consuming those applications. Microsoft 365 is probably the most dominant one right now, but for some of you, maybe it's Salesforce.com and others. But it doesn't matter what they are. They're outside of the network. They moved off premises. But the users at the remote sites still have to come to the data center to get to those applications because that's the only way to get to the internet. Well, the first thing that comes up when I take an application from my data center and I put it somewhere else is security. How do I maintain control over it? How do I guarantee that only users that are supposed to be allowed access can actually access the application? But more importantly, in the data center, there was an existing security infrastructure, an existing security posture. Now that application is outside of it. Can I secure it? Of course I can. All the cloud providers offer some set of tools, and manufacturers like Fortinet offer products as well that operate in the cloud. But am I now managing two separate environments, my on-premises environment and the stuff that's in the cloud? So there's a number of aspects to this security issue. But from a practical purpose, there's a bigger issue. And I just alluded to it a moment ago, is the sheer volume of traffic. The issue with MPLS, what you buy is based on how much bandwidth you need. And most organizations go through a planning process, they calculate how much data will be generated, and they buy accordingly. Unfortunately, the planning process is never, to nobody's fault, it's never accurate because they make certain assumptions. But those assumptions don't include how many applications, both authorized and unauthorized, are out there. How much internet traffic is going to grow in a given amount of time. About the same time, we also had this thing, IP telephony, come in, which was completely unexpected. So all of these things take effect, and what happens, the pipe that I'm buying is too full. The end result is my applications are suffering. The users can't be as productive as they could be because they have to wait for the application to respond or wait to even get to the application. So this, in its heart, is really a networking problem. What's the solution? Well, if it's a networking problem, what we lacked back in the 1990s was a readily available economic source of bandwidth. We have it today, the internet, broadband, whether that be DSL, fiber, 4G, 5G, whatever the case may be, it's there, it's cheap in comparison to MPLS for the most part, and we can get it anywhere, even if we have to use technologies like satellite. So by equipping my branch offices with SD-WAN and allowing them to hook up directly to the internet, I'm starting to alleviate the overload that's on that main circuit between the MPLS network and the data center. Now they come into the internet and they can either go to the cloud applications or they can go down into the applications that are still in the data center. But of course, for every action, there's an equal reaction. And the reaction here is, hey, the internet is cool, but it's insecure. And if I'm taking my business offices and I'm putting my business data over the internet without securing that remote location, it's like leaving the keys in the front door of the house and walking away, just waiting for the first not so honest person to give it a try and see if they can get in. Because in that previous architecture, there is a time dynamic between networking and security here, that these networks grew up before there was really practical cybersecurity technologies. When they did come around, they were put into the data center where the applications are. That's where everybody's going to. So why not? I can centrally administer it. I can set policy of who can go where and control it from there. But now, and also one other point, in the branch offices, because the underlying assumption was it's an MPLS network, it's somebody else's network more importantly, I don't need to worry about security at my remote sites. All of my security is at the head end, it's at the data center. And so as soon as I start allowing users or branch offices to bypass the data center, getting to the applications in the way that SD-WAN does, I'm removing whatever protection those remote sites were under. So that's my second issue here. And remember, SD-WAN was developed and still is a networking technology. There's no mention of security within SD-WAN. And every SD-WAN provider has had to come up with their methodology, their way of bringing security into the equation. And in the early days, it was a real mess because it was all over the place. It's cooled down a bit now. It's fairly standard what most organizations are trying to do. But still, you as a user, when you're evaluating SD-WAN, what makes it secure from that particular vendor? So that's the next stage. That's my next digital innovation. The third one, and certainly what we've been dealing with for the past 2 years, is not necessarily work from home, but work from anywhere. I mean, my own work pattern is a perfect example of it. I'm in the office some days a week. I'm working from home some days a week. And I'm working remotely, whether it be traveling or whatever, some days a week. Now, connecting is not the issue. We have VPN technology, connect to my local internet connection at home. I can get into the corporate network. A VPN helps to protect me, helps protect my data while it's in transit. But again, if I worked exclusively remotely, I could deal with that. Because I know, or the company knows, that I'm working remotely and they can set up the necessary technologies, the necessary security implementation to deal with it. But when I'm bouncing around on no given schedule, and some days working remotely, some days in the office, that's the issue. Because the same thing, like with SD-WAN, because this is sort of an extension of it, as soon as I change location, what I need is security or policy to follow me. What applications do I get access to? Now, you can do this through authentication. You can do it in how applications are actually implemented in organizations, but most organizations don't do it. Once you connect to the network, you get access to pretty much everything. Yes, you might have to log in several times. Single sign-on helps with that. But the point is, trying to maintain a consistent security policy to that user. What's their security profile? Where are they allowed to go? Do I trust them or not? Those are the issues that we have here. So here are 3 different digital innovations. And every time I've done it, I've reached some sort of a problem, or I've arrived at some sort of a problem. And that's, of course, what Murphy's Law says. It dictates things that always go wrong. Now, considering where we are today and the weather report, Did anybody wash their car last week? Because the way the arrangement had been up here, it's going to keep on for a while. Now, how does this apply to what I'm talking about? It's the same concept. What will go wrong, what can go wrong, will go wrong. So here, applying Murphy's Law to cybersecurity, the applications move for all the right reasons. But there's an immediate security question of how do I secure those particular applications? Then, I also then have the performance bottleneck, all of those issues I talked about before. Well, I'll bring in SD-WAN, but that brings in another security liability. How do I deal with that? And then at the same time, I have this work from anywhere problem to deal with, which gives me yet another security issue to work with. Now, that diagram I had up before is very simplistic. This one is a little bit more in detail and more in line with what we see in most organizations. I have remote users at different locations on different devices going to any number of different applications, on premises, off premises. We'll even bring in this thing called cloud computing, which is supposed to be a big thing according to our friends at Gartner. This idea that I'll put compute resources, I'll decentralize my resources and put them closer to the user. Whether it takes off or not, nobody can tell. But the key point about all of this modern network has any number of what we call edges. Now, an edge is not a new thing. It's just become more prominent because of the cybersecurity risk involved with it. And what is an edge? An edge, quite simply, it's a trampoline. It's you as a user on a device connecting to the network, regardless of how you connect to the network. It's a transition between networks. You're sitting at your desk on a wireless network, your data's going out over the wide area network, that's an edge. The connection to the internet is another edge. The connection to the cloud, all of these edges. What is the issue here is not allowing you they don't interfere with connectivity. You can get to any application you want as long as you have access to it. The issue is visibility and security. And it changes the look of this network to something that resembles a jigsaw puzzle. Because now, different technologies, different vendors are typically in the mix. It's in the inability to monitor, to have visibility, and to have a consistent security posture. Now, that doesn't mean one vendor. What it means is guaranteed security no matter where you are, no matter what device that you're on. So when we look at it, all of those edges need to be protected. There's no question about that. There's plenty of options on how to do it. The question is, do I mix and match? Do I bring in 10 different vendors or 10 different solutions to try to do this? You can. And if you're a big enough organization, you might have the skill set, you might have the necessary people to allow you to do that. But what we see, most organizations are trying to simplify. They're trying to reduce complexity. And so limiting, not limiting to one vendor, but a more manageable number of vendors, and more importantly, that each one of those vendors can interoperate or have some degree of interoperability between them. So I want to make sure wherever these edges exist, I'm putting the right technology in place to secure that particular edge. And hopefully I have a vision of doing this that makes sure I now have security consistency as well as visibility. Now, this is a concept that's been growing for a while. And again, our friends at Gartner made an announcement recently, this idea of a cybersecurity mesh architecture. This idea that, I'm sure everybody in the room has heard the expression that the perimeter is gone, it's dissolved. I don't buy that for a moment. The perimeter is still there. It's just moved and it's fragmented, but it is there. And the objective is to put security as close to the user as possible. And with a changing, fragmented perimeter, you have to change how you do it. You can't build walls around the network anymore. The security has to be flexible. The security has to be dynamic. And it has to work together. That's what this whole idea of a cybersecurity mesh is simply because the threats against the networks, against your organizations, are faster, more sophisticated, and more numerous than ever before. And if you can't keep up with the threat landscape, your network, again, is just waiting to be infiltrated. Now, from a Fortinet perspective, our way of addressing this problem, which fits into the definition of this cybersecurity mesh architecture, is what we call the Fortinet security fabric. This is a collection of security technologies that you can apply across the entire network, what we call the attack surface, and having the right technology in the right place, and they're all designed to work together. And one other key aspect of any mesh architecture, particularly with the security fabric, is the idea that products are essentially static, but the threat landscape is very dynamic. It changes on a minute-by-minute basis. The only way that network can keep up is through a continuous feed of threat intelligence, telling these boxes to update themselves, and not doing it in the Microsoft way where everything gets disrupted, doing it automatically and continuously with no intervention on your part. It's this idea of a consolidated architecture, consistency, a single management perspective, a single security operations perspective, and with the ability to integrate other vendors' technology into the scheme. That's what digital innovation is about, securing it properly and doing it in a way that it increases your security profile, reducing your complexity, and minimizing the possibility of successful data breach. I hope that's been informative. I hope it's been interesting. And I think we're just about ready for lunch, so thank you very much. And hey, I'll buy lunch for everybody upstairs. Thank you.